Okay, let's look at part 2 of the review for the final exam. I will work problems 12 through 23 in this video, and then I'll put the link for the remaining problems as well as 1 through 11 in the comments here so that you can access those if you need them. Let's take a look at the first one. It says Sammy spends at least 10 hours a week doing homework and practicing. She spends more than twice as much time practicing as studying. She spends at least 3 hours on homework. We're writing a system of inequalities. So let's let H be the time spent on homework. Just so it kind of makes sense, right? H with homework. And then let's put P for practice time on the instrument. Okay. Now we're going to break down each sentence here. So notice that in sentence 1, she spends at least. So at least is keywords for greater than or equal to. So, and she spends at least 10 hours doing homework and practicing her instrument. So, homework and practicing the instrument are at least 10 hours. And that's how I translated the words into the inequality. Now, the second sentence says she spends more than twice as much time practicing as studying. So, try twice as much practicing as studying. So more than twice as much practicing. So 2 times practicing, right? Twice as much practicing as studying. And then it says that she spent, oops, not studying. That was homework. And then she spends at least 3 hours on homework. So at least again, we have homework is at least 3 hours. And that's translating our words there into the inequalities. So watch those key phrases that I've highlighted for you. Let's look then at number 13. We want to write a matrix to represent the system of equations. Notice in this problem, we're not actually asked to solve the matrix. We just got to set it up. So remember how a matrix works. You're going to take away all the variables and be left with just the coefficients. Watch out for the coefficients that aren't written. So remember, there's an understood 1 there, an understood 1 here. All of these have understood 1s. So let's use the first row. I've got 1, 1, 1, and a 2. Because remember, we're going to include those constants. Watch your second row. I've got 2, -1, 4, and 12. And our last row, -5, -2, -3, and -10. Now I'm going to go ahead and put the matrix, the bracket, excuse me, around those. And a lot of times we'll see a dotted line here between the coefficients of the variables and the constants. But that's how we set up a matrix that we could use to solve the equation. Okay, let's look then at number 14. Now, if you're going to have any problems on the exam, I would suggest using the Desmos graphing calculator. There's nothing in the test that tells you you can't, so let's make sure we have that open and ready to go. I'm going to share mine so you can see that. All I do is Google this every time because I don't remember the web address. So just Google Desmos graphing calculator. It's going to come up for you. Let me share mine with you so that you can see it. 2 seconds here. There we are. All right, switching some things around here. Now, let's put this equation in our Desmos graphing calculator. So I've got y equals, I'm literally just typing this with my keyboard. Parentheses, x minus 4, close parentheses, use the little caret to get your exponent, right arrow, plus 1. And looky there. Desmos graphs it for you. Now watch, if you'll hover over the point, it even tells you where it's at. So you can go on your graph and for 1, put that vertex there. You're going to have some really nice points to work from. Now I can hover some more, but it doesn't look like Desmos is giving me any more exact points. That's okay. I have enough to make my sketch. The reason I have enough is because I can easily see the parabolas turning up, and that key point, remember, that's called the vertex. That's really important that you get that in the right location, and I think Desmos does it beautifully here. So feel free to use your Desmos calculator when you're working on these problems. Okay, I'm going to switch back, friends. We may need to come back to that Desmos calculator here in a little bit, and we will. So my suggestion when you're taking the test, have your review right beside you because you can go problem by problem, and have your Desmos graphing calculator open in another tab so you can use it. Okay, let's look then at number 15. A water balloon catapult, ooh, doesn't that sound fun, is placed on top of a school building 25 meters above the soccer field and launched. Just makes me giggle just thinking about it. I've got this beautiful equation that represents the height. What time will it hit the ground, and what is the greatest height it went up before hitting the ground? Well, friends, we've got some good resources here. We're going to use that Desmos calculator again. Now, let's break down this question, okay? Because I want it, there's two parts, and I want to make sure I get both of them. So, at what time will it hit the ground? That's the first question. That is code for what is x when y is 0? Okay, that's one question we have to answer. And then the second one is what is the greatest height? So let me translate that one for you. That is asking us what is the y value of the vertex? Okay, so I just took it from math speak to actually what am I going to do with that? Okay, so let me switch back over to our Desmos calculator. There it is. Let's clear out this old equation that we used last time. We're going to put in our new one from this problem. So I've got y equals -5. Now this time I'm going to use x instead of t. I know the problem had a t in it, but Desmos will understand it better if I put an x there. Okay, so let's put my equation in there. There we go. Now, do you see how Desmos did all of that work for us? Now, friends, I'm going to have to move over our document camera so you can see here in a minute because I want you to see this beautiful point. Desmos found the first one right there. You see it? Remember, our first question was, what is x when y is 0? And just by hovering over that point, I find that x or t would be 5. Okay, remember what the first question asked us is what is x when y is 0? We just found it was 5. Now, the next question asks us what is the y value of the vertex? Well, my vertex is up here. Now, if you have one of those scrolling mouses, what I'm doing, so mouses, if you have one of those scrolling mice, you know what I'm talking about. You can just use your scroll down. If you don't have that, just use your minus here to zoom out so that you can see the top of that vertex. You just want to hover over it. Do you see the y value there? The y value of the vertex is 45. That answers our second question here, that it is 45 meters, in fact. And I know it's meters because they told me it originally started at 25 meters. Friends, use your Desmos graphing calculator to help you. It's really going to make things a lot simpler if you can use it to graph your equations and then use your hover feature to find out what those exact points are. All right, I'm going to switch back to our document camera because we answered both parts of number 15 there. Okay, let's go ahead and look at number 17. Oh, okay, we're going to have to find the parabola that models the values in the table. This one, I think we're going to use that Desmos calculator one more time. Okay, let's switch over to our Desmos calculator again. I want you to see that I have gone in and put a table. Now, let me back up so you can see how I got that table. I just used this plus here and I put table in there. And then you can type using your keyboard each of the values in the table, excuse me. And I just use my right arrow, or you can click your cursor to go to the next row. Now you have to tell the calculator what you want it to do. Okay, so I'm going to write this down on my note sheet because you have to be very specific about the way you want it. That's what we're going to have to type in. We have to tell Desmos we want all of these features and so I have to tell it in a very specific way. But I want you to see what Desmos is going to tell me. Do you see these values down here at the bottom? Tells you A is 1, B is 4, C is 20. I'm going to write those down. A is 1, B is 4, C is 20. Because what I'm going to do is substitute those into my equation. I've got y equals A is 1, so I've got 1x squared, plus b is 4, 4x, plus c is 20. And there's my equation. Okay, Desmos did all of the work for me, but I have to know how to tell Desmos what I want and how to give it to me in that format. Okay, I'm going to switch back to our document camera because we're going to work number 17 next. Okay, when we're dealing with imaginary numbers and we're trying to simplify, which means we're trying to get that imaginary component out of the denominator, we multiply the top and the bottom by the conjugate. Remember, conjugate has the same terms, so it still has a 1 and a 3i, but it has a plus instead of a minus. We have the same thing on the top. I go ahead and put in the parentheses because I know I'm going to have to FOIL. Okay, so let's see what that looks like. I've got first times first. 2 times 1 is 2. 2 times 3i is 6i. 3i times 1 is 3i. And then 3i times 3i is 9i squared. All divided by, and we have to do the same thing in the denominator. So 1 times 1, 1 times 3i, negative 3i times 1, and negative 3i times 3i, which is negative I squared. Okay, let's simplify. I know you're thinking, I squared, I know that, I know that. Just be patient. We're going to include that here in just a minute. So I've got 2 plus 6i and 3i give me 9i plus 9i squared over 1 plus 3i minus 3i cancel. Then I've got minus 9i squared. Okay, now we know, now it's time to use that I squared. We know I squared, we're just going to put ourselves a little note here, I squared equals -1. So let's make that substitution for I squared is -1. Okay, now on top we have 2 plus 9i plus -9. And on the bottom, I've got 1 minus -9. So now I've got 2 minus 9 is -7 plus 9i over 10. And you'll remember from our work in that unit that a lot of times we split those up into two fractions like that. So I want you to be prepared to see either one, either format, either written as a fraction, one fraction together, or written as two fractions being added together. Either one technically is right. I want you to be prepared for either one. Okay, let's move on to number 18. We're looking for the system, the solution of this system. And now we're going to use substitution. So let's go ahead and take this first equation and let's solve it for y. The way I do that is to subtract x from both sides. So I've got y equals -x plus 5. Now we're going to make this substitution in for the y in the second equation. So in place of the y here, I'm putting in -x plus 5. Notice I put it in parentheses so that I would be sure to square it. So I want you to be thinking of that one as -x plus 5 times -x plus 5. Think about foiling that to get x squared minus 5x minus 5x minus 25. Don't forget your other x squared equals 25. Now, let's go ahead and combine like terms. I've got 2x squared minus 10x minus 25 equals 25. So I'm going to go ahead and subtract this 25. I'm hoping this will factor because I think that factoring is a lot easier method than, let's say, completing the square or quadratic formula. So it looks like I can factor out a 2. So I'll make that change. So I'm just going to factor out a GCF of 2. And it doesn't look like it's going to factor. Ooh, bummer. Bummer, bummer, bummer. Okay, so friends, I tried it, but it didn't work. So let's go to our handy dandy Desmos calculator. I know you're thinking, well, why didn't we try that first? Well, sometimes we don't know, right? Sometimes we have no way of knowing what method's going to work. The good thing is I'm going to be able to type in these equations as is. One reason I like Desmos over the other calculators that are available. So if you have an 84, that's probably going to give you some problems. So I would encourage you to switch over to the Desmos just for this problem. I like your 84 as well, but sometimes Desmos has the power to graph functions or things that are not functions, like this circle here. Okay. The beautiful part, you can hover right there, tells you one of the solutions. Notice I looked for the intersection. One of the solutions is 0, 5. And then hover over here for the second solution, which is 5, 0. Boy, was that easy, right? Boy, was that easy. So take advantage of the resource that you have here with your Desmos calculator and the fact that it could graph things that were not functions. So, okay, switching back over to my document camera because we're making great progress, friends. We've got a little bit more to go. What type of conic section is given by this function? I'm sorry, not function, by the equation. What is its domain and range? Can you guess where we're going with this? You're right. Go back to that Desmos calculator. Man, it's a powerful tool. We're going to put this equation in there and see what our graph looks like. We'll be able to tell if it's a circle, an ellipse, a hyperbola, a parabola. But let's type it in. I've got 16x squared plus 9y squared equals 144. And it graphed it for me. Okay. Now I'm going to zoom out a little bit. Zoom in a little bit. Notice I'm just hitting that plus button there. So it zooms in. I can easily see this is going to be an ellipse. So I know this is an ellipse. I'm hoping you're making a note on here that we graphed it on the Desmos calculator. I probably should do that for my notes too. All right. Now, domain. Remember, that's x's. So I want you to hover here. Notice that x is a -3. And then hover here. Notice this x is a 3. So I know my domain stays between -3 and 3. Check how I'm writing that out. I've got -3 is less than or equal to x, which is less than or equal to 3. I'm going to do the exact same thing for the range. Go down to the bottom and hover there. It's at -4. Go up to the top and hover there is at 4. So I'm going to write my range that it starts at -4 and it ends at 4. Now, friends, as long as I can use my Desmos calculator, I just need to focus on doing the analyzing part, which I think you can do with a little bit of practice with it. All right, switching back to my document camera so that we can continue with number 20. A mirror has a parabolic cross section located at the focus of the mirror. The pipe is located 7 inches from the vertex. Write an equation of the parabola that models the cross section of the mirror. Assume that the parabola opens up. So we're going to be writing an equation here for this parabola. Okay, I had to move some things around because I think this chart's going to be very, very important for us. Remember, it told us in number 20 the parabola turns up. So that means that we're working with the vertical parabolas, okay? It told us that the pipe is located at the focus. So we know that C here is 7 because it told us the pipe was 7 inches from the mirror. So we know that C is 7. But look at how our format comes. Our function looks like y equals 1 over 4c times x squared. Now, friends, you don't have to memorize that. You've got the chart right here in your notes, in your review. So use it. All you needed to be able to do from this problem was to pick out the value of C, which they told you the mirror was at the focus, and I'm sorry, the pipe is located at the focus, and the pipe was 7 inches from the vertex. That's code for that's C value. So we'll plug in C down here in the denominator so that I've got y equals 1 over 28 x squared. Voila, right? You can do this, even if it's a word problem. You're looking for those key phrases like we did too, and have your chart there underneath 21, but use it on number 20 as well. Okay, let's look at number 21 then. Obviously, we need that chart for something. Let's look and see what we need it for. We are asked to find the vertex, the focus, and the directrix for the parabola with this equation. Now, we see it's a y equals x squared. So again, we notice we're using these. And it looks like we might be looking for this here. So we're going to be completing the square, it looks like. Let's set that up. I've got y equals x squared minus 8x plus a blank plus 11 minus a blank. Now those blanks are there to create space for what I would do when I complete the square. Now, you're going to take this number here, -8, and we're going to cut it in half. That'll give me -4. Before it goes in the blank, though, it's got to be squared. So again, let me rephrase what I did there. I took the -8, I cut it in half to get -4. I squared it, and now I'm going to put it in the blank as 16. All right, now we are ready to complete the square. See, x squared minus 8x plus 16 is going to factor into a parentheses squared. That will have an x in it, and the -4, it's the other piece that goes in the parentheses. Then I have 11 minus 16, which gives me -5. Now remember, we're looking for the vertex. That's our h and k. I can pick that out pretty easily. So my vertex here is 4, -5. Now for my focus, I'm going to need my C value. And remember, my C value in my formula comes from in front of that parentheses. Well, that parentheses has a 1 understood in front of it. So I've got 1/4C, 1/4C equals just a 1. Notice what I did. I took the formula, 1/4C, and I took the understood 1 that's here, and I set it equal. Now I want you to think about cross multiplying so that C is 1/4. Now my directrix, my focus says, hey, just add that to the y component. So my focus is at 4, -5 plus 1/4. Okay, I took my vertex, I added my C value to my Y value so that I get 4. Let's see, -5 plus a quarter. If you want to do that in your calculator, I'd probably write it as a decimal. That'd be super easy, wouldn't it? Now my directrix. Again, friends, I'm using my values in the chart here. Okay, I've got y equals k minus c. Now remember what k was? That was the y component of our vertex. So I've got -5 minus c, which we found over here to be 1/4. And again, if you want to use your calculator to get a decimal there, I think that would be very smart. Okay. All right. Let's look. We've got 2 more to go in this section. You're doing great. Number 2, what is the equation for the translation of this 4 units to the left, 7 units up? Now think about what this is. This is a circle, right? If you want to put it in Desmos, you can look at it, right? But I want to go left 4, so that means I'm going to have to move this 4 to the left. Think about how I do that, right? So if I'm going to go 4 to the left, I'm going to have to add 4 in there. Now you may be saying, whoa, 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 left would be minus. It normally would, but when it's in a parentheses, I have to go the opposite of what I naturally would think. And I'm with you. Left is minus. So I'll go the opposite since it's inside of a parentheses. Same is true with the y's here, right? If I want to go 7 up, I actually got to go -7. Okay, so I've got x plus 1 squared plus y minus 5 squared equals 9, and I'm done. Okay, if you want to put them in the Desmos calculator, take a look at them and make sure they do exactly what you just said they do, I think that would be wise. Okay, check, double check, all that good stuff. All right, friends, number 23 is probably my favorite one to get to do because it's a freebie. Make sure you do not miss number 23 when we gave the answer to you right there, friends. So I hope this helps with part 2. I'm going to link part 1 and part 3 in the video below. I'm sorry, in the comments below so that you're able to access it pretty easily. But I'm looking forward to you guys doing some great things on this exam. If you have questions, feel free to leave them in the comment below. I'd be happy to answer them. Bye for now, everyone.